This video is for the Beta Club students who are missing class. In class, we are going to talk about isolating a variable. We're going to look at that sheet you got in class on Friday, solving equations and formulas. And problem number 1, what you're asked to do is you're asked to solve for a. So we have the problem 4a plus b equals 3a. So in this case, what's different when we're isolating a variable is that we have multiple variables, and you're not going to necessarily get a number answer for these. You're going to get a is equal to some variable. So let's go ahead and start. We're going to start by collecting like terms. So what I'm going to do is I'm going to subtract 4a from each side. 4a minus 4a is equal to 0. So we're left with b on the left side, and on the right side we're left with a negative 1a. We need to get a completely alone, so we need to get rid of the coefficient of a, which is a negative 1. So we divide each side by a negative 1, and we get a is equal to negative b. So your answer here is a equals negative b. So you'll see a actually equals a variable. We don't get a specific number for our answer. Let's go ahead and do example 2. In example 2, we have c plus d over 3 is equal to 2c. We're trying to solve for c. So what we need to do is we need to get the c's on the same side. So the first thing I'm going to do is I'm going to clear the fraction like we talked about in class. To clear the fraction, we're going to multiply by this denominator of 3. So on the left side, we multiply by 3, and on the right side, we multiply by 3. On the left side, 3 over 3 is equal to 1, so we're left with 1c plus d. On the right side, we get 6c. Now I subtract c from each side. On the left side, we're left with d. On the right side, we're left with 5c. The final step is to divide each side by 5. And we get c equals d over 5. And that's our final answer. Again, it's not a number, but we have a variable divided by 5. Let's do a few more examples so you get the hang of this. Number 3. F is equal to EPD. We're solving for E. So what we need to get rid of is this PD on the right side. This is multiplication, so the inverse is division. So I'm going to divide this side by PD, divide this side by PD. P over P is equal to 1, D over D is equal to 1, so we get 1E on the right side. On the left side, we're left with F over PD. And that's our final answer. E equals F over PD. Number 4. 12G plus 31H is equal to negative 8G. In this problem, we have to solve for H. So we're going to move this 12G over to this side. That's the first step in getting this H alone. So we do that by using the inverse operation. We have a positive 12g, so we subtract 12g. On the left side, we are left with 31h. On the right side, negative 8g minus 12g is negative 20g. And the final step here to get h alone is to get rid of the 31. Since 31 is being multiplied by h, the inverse operation is division. On the left side, 31 divided by 31 is equal to 1, so we're left with 1h. On the right side, we're left with negative 20 31st g. And that's your final answer for number 4. Number 5, y equals mx plus b. And as you'll remember, this is slope-intercept form. This time we're solving for b, which is the y of the y-intercept. So all I do here is I subtract mx, So b is equal to y minus mx. And this, let's compare this to if you had numbers. If you had y equals 3x plus, we'll just call this b. It would be the same thing. It's similar to when you move the 3x to the left side when you're changing it back to standard form. So you're just moving it to the other side. So that final answer was b equals y minus mx. Number 6, v equals r plus at, and we have to solve for r. Subtract at, and we're left with r equals v minus at. Now, your answer can come in different forms. For example, if you put at first and then v second, that's the same. You're allowed to switch the order according to the commutative property of addition. Number 7, 3x plus y divided by c is equal to 4. And in this case, we're solving for c. So what I'm going to do is what we did in class where we cleared fractions just to get rid of the fractions. It's easier to work when you no longer have a fraction. So we multiply by the denominator. C over c is equal to 1, so essentially we got rid of that denominator and we get 3x plus y on the left side. On the right side we get 4c. And then the final step is to divide each side by 4 to get c alone, and c is equal to 3x plus y over 4. Number 8. In number 8 we have 5xy plus n over 2 is equal to negative 6. In this case, we are solving for y. Let's eliminate that fraction, get rid of the fraction by multiplying by the denominator. Over here, 2 over 2 is equal to 1, so we're left with 5xy plus n. On the right side, we're left with negative 12. Next, when we're trying to solve for y, we're going to go ahead and move the n to the right side. We get 5xy is equal to negative 12 minus n. And then last, to get y alone, 5x is being multiplied by y, so the inverse would be division. So we divide each side by 5x. 5x over 5x equals 1. So we are left with y is equal to negative 12 minus n over 5x. All right, the next problem we have is number 9. In number 9, we have m plus n plus 2p is equal to 3, and we're solving for m. To get m alone, I'm going to subtract n from each side to get rid of the n. So we have m plus 2p on the left side, on the right side 3 minus n. Then I'm going to subtract 2p from each side, and we get m is equal to 3 minus n minus 2p. And again, the order of those doesn't really matter because according to the commutative property of addition, we can put that in any order. And these can always be written as addition. 3 plus a negative n is the same as 3 minus n, and plus a negative 2p is the same as n minus 2p, and then we can switch the order all around. So we could move these all around. Maybe I'll move this one over here, so it could be negative 2p plus 3 plus a negative n. So again, the order there doesn't really matter. And that's all the time in this video that we'll have to go over problems. Hopefully that'll give you a good start so you can finish this worksheet on your own. The answers again are at the bottom so you can check your work.